Hi ladies and gentlemen, so today we're taking a look at 6.5, which is operations with functions. So today we'll be taking a look at the following operations: addition, subtraction, multiplication, and division. We'll also be taking a look at the composition of two functions as well. So operations of functions, this is not anything that's really unfamiliar to you, but the notation is different. And so it's just important to understand how this new notation represents something that you've actually already been doing. So the addition notation, it says f plus g of x. So f and g are in parentheses together, and then there's this x on the outside. All it is saying is to take function f and add it to function g. The of x piece, don't be too concerned. It's not another x variable that we're multiplying somewhere. It's just another way mathematicians have used to notate adding two functions. Same thing with the f minus g of x. That means we're subtracting two functions. Fg, where there's nothing written here, the f and g are technically being multiplied together. And then f divided by g of x is dividing those two functions. So let's get started with example 1. We're given f of x is 4x squared plus 3x minus 1, and g of x is 6 plus 2, and we want to add them together. F plus g of x means I'm going to take function 1, 4x squared plus 3x minus 1, and add it to function g, which is 6x plus 2. Now, I'm adding these functions together, so I really don't need the parentheses, and I could just approach this as combining like terms. The only common x squared term, there's only one x squared term, and that would be 4x squared. 3x plus 6x is 9x. And then negative 1 plus 2 is plus 1. And so then that would be our final answer. The next is f minus g of x. So I'm going to take function f, which is 4x squared plus 3x minus 1, subtracted by function g, which is 6x plus 2. Now, going through this one, you do have to be careful because you're subtracting all the pieces in that second function. It's almost like this is a negative 1 that you're multiplying into the second quantity, making it a minus 6x minus 2. You don't have to go through that process, but that definitely is helpful to make sure that you don't accidentally mess up your signs. So 4x squared is the only thing to combine. I have a positive 3x and a minus 6x to get me a minus 3x. Then I have a minus 1 and a minus 2 to get me minus 3. All right, so that is subtracting two functions. Example 2, let's take a look at multiplication and division. So multiplication, I have f times g of x. So I'm going to take function f, which is x squared plus 8x plus 15. And then that's going to be times the second function, which is x plus 3. I'm going to use a distribution method to multiply these, but there are other methods that we've talked about this year that you could use. So I'm going to take the x cubed term and multiply that by the x and 3. So that'll get me x cubed plus 3x squared. And then I'm going to take the 8x term and multiply it by x and 3 to get me 8x squared and 24x. And last, I'm going to take 15 and multiply that by x and by 3 to give me 15x plus 45. From here, I'm going to combine any like terms I can find. There's only one x cubed term, so it stays as is. 3x squared and 8x squared is 11x squared. 24x and 15x is 39x, and then plus 45 because there's nothing to combine without. All right, next, f divided by g. So f divided by g would be function f of x is x squared plus 8x plus 15 divided by function g, which is x plus 3. Now, this question did not specify for you to simplify, but you could simplify this if you wanted to. And you could simplify it by factoring the numerator into x plus 3 and x plus 5, divided by x plus 3, and that would simplify down to just x plus 5. So you don't have to simplify, but you could, and it would simplify down to x plus 5.